You know, we hear so much about building these incredible, mind-blowing AI models. But what happens after that? A brilliant model just sitting on a server is pure potential, right? The real magic, and honestly, the real challenge is getting it out into the world where it can actually do something useful. So let's unpack that journey. Okay, so picture this. You've done it. You've spent countless hours, tons of data, and who knows how much compute power to train this powerful AI model. It's a masterpiece. But right now, it's just sitting there. It's not doing anything. So the big question, the one we're going to tackle is, now what? How do we get this thing from a nice, clean lab environment into the messy, unpredictable real world? So what exactly is that journey from a finished model to a working tool? Well, it's the absolute crucial bridge between an idea on a whiteboard and actual value out in the world. This whole process, it has a name. It's a bit of a mouthful, but you'll hear it a lot. Operationalization. It's really just the work of turning a static model into a live, breathing system that can make predictions, or inferences, as the pros call it, on all new data that comes its way. You can think of it like every model has two lives. First, there's the training phase. That's its schooling, where it's learning from tons of data in a controlled setting. But what we care about today is its second life, the inference phase. This is where the model graduates, gets a job, and starts applying what it learned to brand new situations. This is where it actually creates value. All right, so we know we've got to operationalize the model to get it to that inference phase. But how does it actually make those predictions once it's out there in the wild? Turns out, it's not a one-size-fits-all kind of deal. The first way is what we call batch prediction. Think of this as the slow and steady approach. The system just gathers up a huge group of data, like, say, all of a company's sales from an entire day, and then processes them all at once, maybe overnight. It's perfect for things like generating reports or analytics where you don't need an answer that very second. And then you've got the total opposite, real-time prediction. This is the right now method. When you use your face to unlock your phone, or your bank's app flags a weird-looking transaction the instant you swipe your card, that's real-time prediction in action. It absolutely has to happen in milliseconds to be of any use at all. So you see, we have these two really distinct paths. Batch processing is the cold path. It's slower, it runs on a schedule, and it's fantastic for chewing through big chunks of data. Real-time is the hot path. It's instantaneous, working on one little piece of data at a time. The right choice just completely depends on whether you need that answer later or you need it right now. So we know how the model can make its predictions. The next huge question is, where does it physically live? And this is not a small detail, believe me. This decision impacts everything: cost, speed, security, you name it. First up, you've got on-premise. The best analogy here is owning your own house. The AI runs on your company's own servers, tucked away safely inside your own network. You have total control, which is awesome for super high security stuff, or if you have strict regulations to follow. But just like owning a house, you're on the hook for all the maintenance. Option 2 is the cloud. Now, if on-prem is owning a house, the cloud is like renting a super flexible, scalable apartment. A provider, think Amazon, Google, Microsoft, handles all the hardware and the infrastructure for you. It's amazing for scaling up or down whenever you need to, and lets you access your AI from anywhere. The trade-off, well, it can get pricey, and you do give up some of that direct control. And that flexibility is exactly why the cloud and AI are such a perfect match. It lets developers build things using what's called a microservice architecture, basically breaking a giant AI system down into small, independent little services. That way, you only pay for the exact service you need right when you need it. It's a really powerful combo. And finally, we have the edge. This is a cool one. It means the AI model lives directly on the device itself: your smartphone, a smart camera, an industrial sensor. This is absolutely essential for speed, for privacy, and for situations where there's no internet connection. When your phone unlocks with your face, that model isn't in the cloud, it's running on the edge, right there in your hand. Okay, so we've picked a spot for our model, on-prem, in the cloud, or on the edge. We deployed it, job done, right? Let's pack up and go home? Heh, not even close. Deploying an AI model isn't a set it and forget it kind of thing. It's an ongoing process. It needs constant care and feeding. And this is where we get to our final key term, MLOps. That stands for Machine Learning Operations. MLOps is basically the whole discipline of managing the entire lifecycle of a model to make sure it keeps performing well long after it's been deployed. Think of it as the forever job of keeping the AI healthy and effective. MLOps really has two sides to it. On one hand, you've got DevOps for ML. Think of this as the plumbing. It's the IT process of packaging and deploying the model so it works reliably. The other side is model-specific ops. This is all about the model's brain. Is it still making good predictions? Is the world changing in a way that's making it less smart? And that is the crucial point right there. The world changes. Imagine an AI trained to predict housing prices back in 2020. Well, the data it would see today in 2024 is completely different. This phenomenon is called model drift, and it can cause a once brilliant model to slowly become useless. MLOps is basically the constant fight against that decay. And what this really means is you're not just managing one life cycle, you're actually managing two. You got the model's life cycle, retraining it, updating it, but you also have to manage the life cycle of the data that's feeding it. It all comes back to that classic saying, garbage in, garbage out. You have to be asking, how is our data being collected? How are we storing it? Is it secure? How are we tracking its quality? If the quality of the data going into the model drops, well, the quality of the model's predictions is going to drop right along with it. So, to wrap this all up, let me leave you with a thought. The next time your mapping app instantly reroutes you to avoid traffic, or your social media feed just perfectly curates that next video for you, just stop and ask yourself, how is that prediction being made? Is it batch or real time? And more importantly, where is that AI actually living? Is it on a server somewhere, in the cloud, or is it right there on the device in your hand? Suddenly you'll start to see this hidden world of AI operationalization is all around us.